Okay, this is our famous ambiguous case, the angle side-side or side-side angle. In other words, we know two sides, but not the angle in between. We know a side and then two angles next to it. So what's the problem with this triangle? Why do we have issues with this? So let's take a look at this. If we were going to set up, we know two sides and an angle. So the rule of thumb is that when we know two sides, we use law of cosines. When we know two angles, we use law of sines. So we're going to actually do both, but we're going to start out with the more typical, which is the law of cosines. So if I want to find, given angle P is 30, P is 30, and R is 50, actually I want to find side Q. So here's P, here's R, here's Q, and I want to find side Q. That's what I'm trying to find. Now, what you've done before when you've wanted to find a side is you've said Q squared is equal to R squared plus P squared plus minus 2 times R times P times cosine of, it was supposed to be cosine of Q. All right? So if you're thinking this, Q squared is equal to, don't write this down, P squared plus R squared minus 2PR cosine of Q. The problem is I don't know angle Q, nor can I find it because I don't know R either, and I don't know side Q. So this gives me too many variables, so I do not want to use this. What I want to do is I need to use the angle I already know, and so I'm going to have to use R, angle P and side P. So I'm going to have to say 30 squared is equal to 50 squared plus Q squared. Okay, I don't know Q, but I'm going to have to write it in there like that. Minus 2 times 50 times Q times cosine of 30 degrees. Okay, so now this was just coincidence that my angle and my side were the same length. Don't think that always happens. Now I have to solve this, but I have a Q squared and a Q. You're thinking Q squared and a Q, is this a quadratic equation? You're darn right it is. It's a quadratic equation. And when we solve a quadratic equation, we set it up generally equal to 0 so that we can either factor it or use the quadratic formula. So that's exactly what I'm going to do. I'm going to set this equal to 0 and say, and put my Q squared first, Q squared minus, well, all of this is all one term. This is my Q term. So this is negative 100 cosine 30 times Q. So minus 100 cosine 30 times Q, and then I have 50 squared minus 30 squared. So 50 squared is 2500, 30 squared is 900, so this would be plus 1600. 2500 minus 900, 1600. So there is my equation. Now, how do I go about solving this? Well, this is a quadratic equation. I could think of this as 1 Q squared, so A is equal to 1, B is equal to negative 100 cosine of 30, and C is equal to 1600. And somehow I've got to put this mess into the quadratic formula. So let's remember the quadratic formula, and we should sing our song. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. If you remember that, you will remember the quadratic formula. You might want to sing that to yourself a few times. Pop Goes the Weasel is the tune. Now, what I would suggest doing is to store these three values in your calculator as A, B, and C, and then just type in the formula. You'll have to do one with a plus and one with a minus. Actually, you might be able to do both at the same time. Let's check this out. So, opening up my calculator, add a calculator page. So, first I'm going to say 1 and store. Your store button is above your variable button. Control variable, 1 store A. Okay, so that means anytime I type in an A, it'll be bold now and it'll just automatically give me 1. Okay? Then I'm going to do negative 100. No, I don't want answer minus. I want negative, so I'm going to use my little negative sign here. Negative 100 cosine of 30. I'm going to make sure I'm in degrees. Yep, I'm in degrees. Cosine 30. And I'm going to store that to B. So control variable, store, and put in my B. Okay. And then I'm going to do 1600 and store that oops, wrong one. Control, store that to C. Now I just have to type in the quadratic equation. So I'm going to use control division sign to make a fraction here, and it's negative b plus or minus. Now here's a way you can do plus or minus all in one step. You can say plus curly bracket 1 comma negative 1 and then times the square root of b squared minus, now here you have to be careful, 4 times a times c. Now you have to make sure to put a times between a and c because your calculator can name a variable as ac, like the two letters together. So you have to put a times in between. And then 2 times a. I think if you just type 2a, it'll automatically do 2 times a. But now, because of the curly bracket, it's going to do negative b plus 1 times all of that, and then negative b plus negative 1 times all of that. So that's my plus and minus. Push enter, and I get 2 answers. Oh, those aren't terribly helpful. I think I'm going to put those into control enter. Okay, so those are my 2 answers. 59.88 and 26.71. Interesting. And I think I'm going to go back up here. I want to copy something. Okay, I copied my work here so that I could bring it back over here. So this tells me that x, and I put x, and I really shouldn't have put x. I should have put q because really that's what I'm solving for in my equation here is I'm solving for q. So q is either equal to 59.88 or 26.71. Now how can that be? How can I get 2 different answers for q? Well, the reason is because this is a side-side angle triangle and rather than a side angle side. This side QR, this side P, actually we'll call the side P here, P can be put in more than one spot. I could have a triangle that looks like this, 50, 30, Q. So here's 50, here's 30, here's my angle 30. Or I could draw that same side over here. My 30 could be over here. So this angle is not fixed right here. So this angle could either be this little blue angle here, or it could be this bigger red angle here. And so this side 30 kind of pivots. It could go either here, and that's probably not a very good drawing of where it could go because that doesn't look the same length, but it could go 2 different places. So side Q could either be this length from here to here, or it could be all the way from here to here. So it's 2 different triangles. Now, could I do this with law of sines? If you look at the other video I put up about the ambiguous case, you'll see an example of this done with law of sines, but they find the angles first. So that way you find both different angles, and then from those angles you could find the sides. Here, from the sides, I could find the angles. Once I know the sides, I could use law of sines or law of cosines then to find the missing angles. But I would have 2 different triangles. So one time I would have a triangle that would be 50, 30, 59.88, and another triangle would be 50, 30, 26.71. And I could find the angles then, the missing angles for those 2 triangles. Now, does the ambiguous case always result in 2 triangles? Not necessarily. Here's another example. If I do the same, put the same numbers in here, and I'm just going to show you an example of this one already done. So let me find that. So if we take a look at this problem here, if I draw 25 here, I put 25 squared in because I'm looking now, I've changed P to 25. Everything else is the same. 25 squared equals Q squared plus 50 squared minus 2 times Q times 50 times cosine 30. Now I have Q squared minus 100 cosine 30Q. So all of that's the same, but I've changed this number here. So now I do 50 squared minus 25 squared and I get 1875. And here's my A, my B, and my C. When I do the quadratic formula this time, I get 2 identical answers. When I get two identical answers, it means there's exactly one possible triangle, and also that it is a right triangle when these two numbers are the same. Now, is that the only possibility? No, there's a third possibility. The third possibility is this one. Actually, there's four possibilities, I forgot. Another possibility is this side now is 60, okay? So we have 50, 60, and 30 degrees. So when I plug in the numbers, the only thing that changes is this becomes 60 squared. And when I solve it, I get a negative answer and a positive answer using the quadratic formula. So here, A would be 1, B would be negative 100 cosine 30, and C would be negative 1100. I get two possible answers, but one of them is positive and one's negative. Well, only the positive gives me a triangle. What happens with this negative number, though, is that would be what happens if I take this side over here and I swing it back this direction. So if this were 60 from here to here, if this were 60. Now, is that a possible triangle for this angle and this side? No, because this angle is inside this triangle. This is a kind of outside. But that direction right here is actually that distance from this vertex to where that 60 unit side would meet this extended side. That's the negative 11. So sometimes that's useful in a real world context to be able to use that number. The last case, of course, would be there's no triangle at all. So let's say we have this side's only 20. Well, it's too short to reach. We saw that with a right angle, that was a side of 25. So if we do the quadratic formula, what we end up with is a non-real answer. So we end up with something with I in it. And that means it's too short that no triangle exists. So in general, here's a summary of what we've done. For the ambiguous case, the side-side angle case, you would use the law, let me back that up, use the law of cosines and the quadratic formula. If you get two positive real solutions, it means you have two triangles that meet the criteria. If you have a one positive and one negative, then use the positive solution, you have one triangle. If you have two identical real solutions, you get one right triangle. If you have two non-real solutions, you get no triangle. It's not possible to get two negative solutions. If that happens, it means you did something wrong. Usually what has happened when you do that is that you forget this negative sign when you're entering B, and you end up with two negative answers instead of what you're supposed to have. Sometimes that can happen when you have a positive and a negative, and you get them switched around because of forgetting to make B negative. B will always be a negative number. C is sometimes positive, sometimes negative, and A is always 1. So it's really pretty easy to use the quadratic formula with this. So that is law of cosines with the quadratic formula. Now, sorry, that's the ambiguous case with law of cosines and the quadratic formula. You can, as I said, do this with law of sines as well. So check the other video out for how to find missing sides and angles with the law of sines.